Hello everyone, welcome to another new video where we'll be discussing about this program. You need to write a recursive program to find GCD of three numbers. Okay, before jumping into writing a program, you need to understand what is GCD. Okay, let me tell you what is GCD. GCD is nothing but greatest common divisor. Greatest common divisor, fine, and it also has another name, HCF, highest common factor. You have heard this one, but you may not have heard GCD in most of the cases. I'll tell you how you will find GCD. Okay, uh, let us take an example, 9 and 15. They may ask you to find the GCD of 9 and 15. At that time you will be finding the factors or the divisors of both the numbers. In this case, we will find the factors of this number. 1 can divide 9, 2 cannot divide 9, 3 can divide 9, right? 4, 5, 6, 7, 8, 9 can divide 9. So there are 3 divisors for 9. Similarly, take 15, 1 can divide 15, 2 can't divide, 3 can divide 15, 5 can divide 15, and then the 15 can divide 15. Here we need to find, we have found the divisors now. We need to find which are common in this. In this common are this one and then this one. There are two common divisors in this one. You need to find which is the greatest among these. So the answer for this question will be 3. 3 is the GCD of 9 and 15. Okay, we'll take another example which is going to be similar. Okay, so we'll take 24 and 18. Okay, we'll try to find the divisors of 24 and 18. 1, 24, 2, 12. See, I write 1 and divide this 24 by 1, and whatever the answer you get, write here 24. I write 2 here, divide this 24 by 2 and write here. So 3, 8. Then 4, 6. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 divisors. Now consider the divisors of 18. 1 can divide, so write 18 here. 3 can divide, so write, so actually 2 can also divide this one. 2, 9, 3 can divide, 6. So there are how many divisors here? There are 6 divisors. We need to find the common divisors now. 1 is a common divisor, 2 is a common divisor, 3 is a common divisor, 6 is a common divisor, and there are no other common divisors. Now from here it is very clear that here the GCD of 24 and 18 is going to be 6. Alright, exactly, but we cannot use this method in our program. We'll be using another method which is much more refined method than this, because finding the divisors of each and every number is going to be tedious if it is a huge number. Okay, that's why there is another method of finding the divisors. We'll take the first question. What all we have got 9 and 15. You need to find the divisor. Here you not find divisor, you need to find the GCD of 9 and 15. For that, what you will do, you will just consider B here, write 15 here, and here you divide this 9 by 15 and write the remainder. So this will be equal to what? This will be equal to 15 comma, what is the answer of this one? When you divide 9 by 15, what is the answer? 9. So write 9 here. Right, now you take this 9 here and write 15 mod 9. You see, I am writing the first value here, means I am writing A here, and then percentage B. Here I am writing B, comma, A, percentage B. What will be the answer for this one? Write 9 as it is, this 9 as it is. 15 divided by 9. What is the answer? 1, 9. So it is going to be 6. So write 6 here. Now you take this 6 here, right? And then consider this 9 mod 6. So this will be equal to what? 6 as it is. This 6 as it is here, comma. Divide 9 by 6. You got 1 is 6. You got 3. So write 3 here. You need to go on doing this one until the second value, until this second value is 0. Okay. When it is 0, then we will have this as our GCD of these two numbers, 15 and 9. Fine. Now you take this 3 here, 6 divided by 3. This will be equal to 3 comma remainder of 6, 3, 2 the 6, 0. So remainder is 0. Now we have met the final condition. We are trying to make this B 0 by dividing it, and the remaining A is itself GCD of the given numbers. So you understood how we have done. We'll try to solve another question so it will be clear. We'll be taking this example itself, 24 and 18, GCD 6. We'll try to apply this one. We'll take GCD of 24 and 18. Okay. Now you try to find what I have done. I have taken this B here, right? And here I have done 24. Here I have taken B, A, percentage B. This is A and this is B. You need to follow this format. B, A, percentage B. I have taken B here. It means it is going to be 18. And here A, 24 divided by 18. So what is the answer for this one? 18 as it is. You need to find the remainder of this. 24 divided by 18. How much you get? 1, 18. So you are left with 6. Again take this 6. Now it is here A and it is B. You need to consider B, comma, 18 percentage 6. So this will be equal to 6, and 18 divided by 6 is 3 is 18, 0. We got 0. So the GCD of 24 and 18 is going to be 6, right? We'll use the same method. You can see how fast it will be to find the GCD using this method. We'll go for the code, right? You can observe here, it is going to be very simple program. In the question they have asked us to find the GCD using 3 numbers, but we have seen how we'll find the GCD using 2 numbers. You observe here GCD of int A and int B. If B is equal to 0, I have told you at the end, if B is equal to 0, it is going to say that A itself is the GCD. Else we are going to return whatever the B value was here, I am passing it in the first place, and whatever was in the place of B, I am passing A percentage B. You can see here I have written the arrow mark. In this place I am passing A percentage B. In this place I am passing B. Right. This is the logic for finding GCD. Now what we will do in the main function, we are going to declare 3 variables, num1, num2, num3, and we are asking the user to enter 3 numbers, and then we are going to scan the values. It means we are going to take the values num1, num2, num3. First value will be in the num1, num2 and num3, and then for the result, actually you see I have written int here. It means this function has to return me a integer only, then only it will work. You can see, so the return type of this function is int. Result is equal to GCD num1 right in place of A, and in place of B we are going to find the GCD of num2 and num3. Okay, I'll show you how this works. Imagine you want to find the GCD of 3, 9 and 12. First you find the GCD of these two. It's going to be 3 comma I think it is 3. Okay, and the GCD of 3 comma 3 is again 3. So the GCD will be found like this. First you are going to call the function using these two values, and then after finding the value you are going to call the function using these two values, because our GCD function can take only two parameters, integer and integer. You have to pass only two parameters. Fine. As soon as you call that, then you will be able to get the GCD of all the three numbers, store it in result, and try to print. GCD of num1, num2, num3 is equal to result. We'll just check, execute and check this once. We'll clear. Now what we will do is gcc gcd.c, no errors, /a. Now it will ask me to enter three numbers. I am entering 3, 9 and 12. You can see GCD of 3, 9, 12 is equal to 3. Again, if you want, you can go for 2, 56 and 8. So GCD of 2, 56 and 8 is equal to 2. I hope you understood this program. Thank you.